Believe it or not.
In this video we're going to show you a different way of putting the radio vibrator, the solid state radio vibrator, into an existing old defect vibrator can. That vibrator is going to be used for this power supply here. It is a PP282 power supply, and this is where the vibrator goes. Now, in a previous video I showed you a method where we basically make a cut around the circumference, and that is one way of doing it. Today we're going to try what might actually be an easier and faster way. I already did that with this old vibrator from a car radio, and the method is basically to open the bottom by cutting away this crimped bottom, and for that I again use my trusted Dremel tool. For this one we already did that in the past, and I did not glue it together yet to show you the insides. Basically this is a vibrator that only has 3 contacts. It's an asynchronous shunt vibrator. As you can see, the board is held in its place basically by these copper wires, and they are soldered in a pin, which is identical to what we did in the previous video. But here I did not use the plastic ring to keep it in its place centered in the can. I just used adhesive to part epoxy adhesive to mount it on the board, and that is pretty rugged right now. So all I have to do to go to the next step is put it in here, put the adhesive in here, let it dry overnight, and this thing is like rock solid. And that's basically the same concept that we're going to use for this this vibrator. This is a more complex one. This is a synchronous shunt vibrator. It has therefore more pins. Actually, this base has 7 pins, of which one actually is not used, but that is not important. All that matters is that we get this in here in a simple and robust way. Now, what I didn't tell you, this is the new product that we have. This is the Radio Vibrator 2 RVB-2. They come in different models. The old RVB1 was only for negative ground. They come in different models. We have a model that does 6 to 30 volts, just like the original one, which is actually this one that I'm holding right now. For negative ground, we have a version for positive ground. Again, for 6 to 30 volts, we have a version that can handle 2-volt battery radios. Actually, it starts from 1.7, works reliable. I can give you a link to a video where I actually put that in a GE250 portable tube radio. We also have that same 2-volt version for negative ground, positive ground, and we have a version for farm radios, 48-volt farm radios, both positive and negative. So we got a whole host of different products. We actually also have a version that can be enabled from the outside with an enable input. Certain equipment requires that, certain military equipment. But not this one here. This one here is relatively straightforward, synchronous. It's a 24-volt power supply. And we're gonna put the standard product in there, the one that can handle 6 to 30 volts, actually 6 to 35 volts I would say. So let's start doing that, and the first step basically is to open the bottom and get the old innards out of there. Alright, I made a beginning by, basically grinding this away. Now there is several ways obviously of opening this up. You could just nibble it open with pliers, but the end result is going to look unprofessional. I don't like that. Then it's going to look like this. I bought a car radio on eBay a while ago and somebody had done this. It's a real messy job. You see they nibbled it open and they destroyed the base in the process, so that is all screwed up. So that's not the way I like to do it. We need to do this professional. So I recommend using a Dremel tool and just take the time and grind this crimped surface away. And you know, you don't have to be worried about the fact that it's not going to be there anymore, because you can just adhesive it in with the two-part epoxy. It will never come loose anymore. So that the fact that you grind this away is not a problem, but it allows you to make it look more professional. But you know, if you really want to, you could also nibble it open, and then it's not going to look as nice, but it will still do the job. So let's continue the job, and then we'll go to the next step. By the way, when you use a Dremel tool, always use safety glasses, because these grinding discs do have a tendency to end up in your eyes if you're not careful. Alright, let's finish opening it up and we'll go to the next step. Alright, as you can see, I'm pretty far in this grinding process, and the next step is to actually try to get it out. Looks like I'm gonna have to take a little bit more force, but that's basically the concept. You know, you grind away the flange here, the crimped flange, and then you got to pull this out, but it looks like I have to put something sharp underneath here to pry it out. So let me do that and I'll get back. Okay, with this razor blade it came out pretty easy, and then it's just a matter of what you saw in the earlier videos as well, to get the inside out of it. And from there on, we're pretty much on our way to replace this. So you can see this is a typical synchronized model. Has 2 sets of contacts. And what we will do, we'll cut this loose here. And then we'll do the same as what we did in the previous video. We desolder these wires here and blow them clean. Oh, this one is really in bad shape. This rubber is all deteriorated. You know, these things are like 50, 60 years old. So oh, that's an expensive one. Look at that. It's ceramic insulation here. Anyway, we're gonna put our RVB-2 in there, and the next step is to desolder this here and start mounting the RVB-2 board. Now, one thing I'm going to do with the can here, you know, it is already pretty straight the way it came out. Like I said, this looks much more professional than what that other guy did, remember? You don't want your vibrator to look like this, you want it to look nice and professional. So what I do is, to make it really nice and equal, is file this down a bit until it's all in one plane. But you know, I don't have to take off much because it pretty much already is, but this is what we do to make it look perfect. Alright, this is all filed down now. You know, when we're going to put it back in later, it's going to look like this. So that looks quite nice. But for now we're going to put the RVB in. Okay, we got it cleaned out, as you see. So, you know, you can see in my older video how to do this, but you basically heat it up, tug it out, and then blow out the pins. They're hollow. When they're still hot, you know, just blow at it, and the solder will come right out. Now, next thing you're going to ask me is, how are you going to hook that up? Well, that obviously depends on the equipment. You need to figure out for your own equipment what goes where. All I can tell you here is how this is actually configured for the RVB2. It is the same as for the RVB1. I can go over it quickly. What you see here is not used. This is an enable pin that's only used for special versions. What you see here and here are the primary contacts. So this goes to the primary contacts of the synchronous vibrator. This is ground, or the tongue, that is the common contact in the vibrator. And these are the secondary contacts for the synchronous vibrator. Basically that's done here with rectifier diodes. These are 1000-volt diodes, so they can handle a pretty good voltage there. So secondary contacts, ground, which is the tongue of the vibrator, and these are the primary contacts, and this one is not used in most cases. If you buy a special version with an enable input, this is going to be the enable input. If not, then you just leave that one unused. So you basically use 5 contacts, or 3 if it's only an asynchronous vibrator you're after. Because in that case the rectifier is already in your radio and you don't need these 2 diodes, which is actually the vibrator I showed you earlier. This is a version for an asynchronous vibrator radio, and as you see I didn't even put the diodes on there. So in that case only 3 contacts I used. Like I said, this one is not used. These are the primary contacts, goes to these pins here, and this is the ground pin. Ground pin goes to the contact here. Tongue, contact, I actually made a note there. So that's for an asynchronous case, but in this case, for this power supply here, we're going to use a synchronous hookup. I'm going to basically look at the schematic diagram for this equipment, how that is connected. Now what you could do is also use the way the original vibrator was connected. Well, that's a little bit tricky. I'll tell you why. You know, these are obviously contacts. You can see that. This is a contact, this is a contact, this is the terminal for that. Here we see the common contact. That is the center one. So this used to be the tongue or the ground, what I said earlier. And here are the other sets of contacts. The problem is you can't see from the vibrator which are used for primary contacts and which ones were used for secondary contacts. That's why you still will have to look at the schematic diagram, or use an ohm meter to determine that here, because the primary contacts will have real low resistance to the plus terminal of the primary input terminal for that power supply. So that's another way to figure that out. Because, you know, in the original concept with the mechanical vibrator, primary and secondary contacts are irrelevant, but for the solid state that's obviously not true. For the primary we have our solid state switcher here, and for the secondary we have our diodes. So that's why it's still important for you to figure out what is primary and what is secondary contacts. So best case is to have a look at your schematic for your radio. If you can't figure it out, just tell us what kind of equipment you have and we can figure it out. We have a whole library of schematic diagrams for military radios, for car radios, for CB radios, you name it. So ham radios, so we can definitely figure that out for you if you can't come to a conclusion there, and then we can just tell you how to hook it up. But it's pretty straightforward when you have a schematic diagram. Alright, we're going to continue to our solder process here and mount the RVB1 on the base here. Okay, we got the RVB2 soldered on the base. As you see, it has quite a lot of rigidity. I actually didn't even glue it down. It's not really needed because, as you can see, you know, with the synchronous vibrator we have 1, 2, 3, 4, 5 wires to keep it in place, and it's not going anywhere. So in this situation I'm not going to do anything else other than, of course, glue the can shot when we seal it up. But you don't have to use this plastic ring that I did in the older video. Now for the mounting wire, I have, this is not solder, this is a copper wire that is tin plated. I bought this a while ago, and it's quite convenient for this kind of work because it's pretty rigid. Like I said, you don't have to do anything else. Now, one thing that's important is once you have done all the soldering, as you can see, 2 holes are unused. One was for the coil, the other one was already unused. The other ones are for the primary, secondary contacts and for the tongue. Once you have that soldered in, you got to make sure that there is no excessive soldering on the side of these pins, because then you're going to have a problem putting this back into the base, into the power supply, because then the pins are too thick and you might even damage the socket in which this plugs. So you got to make sure that you clean that sufficiently, that there is no solder on the sides, and of course you got to put enough solder in there to make sure that the wiring stays in place and makes good contact. But that's basically all there is to it. Now what I do is, when I put them together, like I told you before, I had figured out what goes where, but I don't know if you can see it, but I wrote down with a marker a P for primary, S for secondary, T for tongue. So you got 2 primary contacts, 2 secondary contacts. The primary contacts go here to these MOSFETs, and the secondary contacts go to these diodes. The order doesn't is not important. So whether you do put it on the left or the right one, or reverse, that's not important. So just note down primary, primary, secondary, secondary, tongue, and then you don't have to constantly figure it out as you are working. This way you just solder it up and you're good. So that's all there is to it. The next step that I'm going to do is, like I said, solder it up, glue it up, excuse me. And then this is basically the way it's going to look. It's a professional look. And there is no cut mark like I had with the other method. One thing you might want to figure out, sometimes there is an arrow here that goes to pin 1. Pin 1 is the, if you look at the bottom, there is 2 thick pins, the rest is thin for this particular configuration, which is like most military radios. And the right thick pin is number 1, and then you just count clockwise 1, 2, 3, 4, 5, 6, 7. And the arrow is usually positioned at pin 1. So if you really want to do it perfect, then you want to make sure that that's lined up as you adhesive it together. Now this one says 6 volts. What you can do, as I showed in the other video, is you can make your own printing. I did that with a toner transfer process. You might want to check the other video how I did this. First you got to obviously remove this, either with sandpaper or maybe with some solvent, and then you can put your own writing on it, marking solid state vibrator from 6 to 24 volts, because this thing can now do 6 to 24 volts. The original one could not do that. So in this way you show to the next owner of the equipment that there is a solid state vibrator installed in the equipment. Don't have to do it, of course, but if you want to do a superb job, then that's what you could do. But that's all there is to it. Much simpler than the other method that I showed you, the previous method. This is rigid enough to stay in place, and you're done. Thank you for watching this video.